In the next part, we are given the surface area of a shot put, which is 616 centimeter square, and we have to get its diameter. Shot put, which you know that it's in the shape of a sphere. And what do we know here is the surface area of this. So we know the surface area, and surface area of this figure is what? This is sphere, that is 4 pi r square. So we know the surface area as 616. So I can equate 4 pi r square with 616, right? And then what we have to get the diameter, clearly, we'll first get the radius and then the diameter. So let's plug in pi as 22 upon 7, keep r square as it is, that is equal to 616. And later if I transpose these numbers like 7 multiplied now and 4 and 22 is divided. Now I'm going to reduce this. This is divisible by 11. So 2 times this is divisible by 11 again. This is 5 times 55 and 6 times. We have 4 into 2, 8, and 8 7 times is 56. That implies we got r square as, there is 1 7 over here and 7. R square as 7 square. So I can say r as 7. Once we get the radius, I can say the diameter is 2 times its radius, which is equal to 14 centimeter. In the next part, the question says that if a sphere of radius 3 centimeter is melted and recast into a right circular cone of height 3 centimeter, then the radius of the base of the cone. So we have one sphere, let's say I made one sphere. This is the sphere which was given, and its radius is given as, this radius is given as 3 centimeter. This is melted and recast into a cone. What you should know that whenever we convert one solid, whenever we melt and recast into another figure, what remains same is its volume. So we can say that the volume of these two figures will be equal. Now we have to get the radius of this figure. Let's say I use capital R for this. And we also know the height of this cone. The height of this cone is mentioned to us. This is given in the question, that is, it is 3 centimeter, right? This is 3 centimeter. So what we have to get is this radius. So I can say that the volume of the cone should be equal to the volume of the sphere. Now I replace this statement with its formula, that is 4 by 3 pi r, and I have taken capital R for the formula of a cone, into h, and that is equal to the volume of a sphere, which is 4 over 3 pi r cube. Now check, we have a few numbers getting cancelled. Pi and pi get cancelled. We cannot cancel r because they are different values. Now we can replace this, we can cancel even 3 here. In the next part, we are going to plug in the values. We are supposed to get r square, so I'll keep r square as it is. The height of this, which is mentioned as 3 centimeters, so I'll write 3 here. That is equal to 4 times r cube, and we have taken the radius of the sphere as given 3. So I'll be writing 3 into 3 into 3. Now further 1, 3 get cancelled. So we get r square is equal to 4 into 9, that is 36, and under root. In order to get r, we'll find under root of 36, that is r is equal to 6. So we were asked to find the radius, and we got the radius of this cone, which is equal to 6 centimeter. 6 centimeter. Coming to the next question, it says that spherical balloon grows to twice its radius. That means its radius gets doubled when inflated. Then the ratio of the volume of the inflated balloon, the new one, to its original. So what we know here, that let's say for example, if I make two balloon, let's say I make this being the first balloon, and then it's inflated so that its size increases. Now we know the radius of here. We know the radius of these two. That means the radius, we actually know that it is being doubled, right? So if I take the radius of this first as say R1 as R, then the second one, say R2, is 2 times R. Now what do we have to get is the ratio of their volume, right? Keeping in mind the inflated, this one should be the first inflated, and to the original is this. So that means we have to if I take the volume of this being V1 and no, say this as V1 and this as V2, then we have to get V2 over V1. It is important to notice that we need the ratio of inflated to the original. Now, V1 is the volume of a sphere, and that should be replaced by 4 by 3 pi R1 cube. Sorry, this is R2 cube, as I told you. It is the inflated first over the deflated or the original one. And this should be replaced with 4 by 3 pi R1 cube. Clearly, we can see that 4 by 3 pi and 4 by 3 get cancelled. So we'll get V2 over V1 is equal to R2 over R1, the whole cube. Now we can I can replace V2 with 2R, and that which say not V2, R2 as 2R and R1 as R, and then there is a whole cube. We can further see that this R also get cancelled. So we'll get this 2 over 1. On cancelling this, R will get 2 over 1, that is 2 over 1, and there is a cube over this, that is equal to 8 over 1, which is 8 is to 1. So therefore, this is going to be the answer for this part. In the next part, we have the total surface area of a hemisphere as mentioned, and we have to get the diameter. So it's a formula-based question. What we can do is total surface area of a hemisphere. As you must be knowing that a hemisphere, which is shaped like this is the shape of a hemisphere. What else we know that this being its radius of the base and its surface area, that is the total surface area, right? TSA. The total surface area of this hemisphere is 3 pi r square. As for the question, this is the total surface area. So I can equate this 3 pi r square with its value, which is 1848. In the next part, we are going to replace pi with its value and keeping r square as it is, as we are interested in finding the diameter. Now in the next part, we are going to transpose these numerical values except the r, that is 7, and this is 3 into 22. Now you have to reduce it. I'm reducing this by 11, 11 two times, 11 one time, then 7 is the remainder, 74, which is 6 times, and then 8 is the remainder, so 8 times. Now, this is further divisible. I am first reducing it by, say, 2. So if I divide it by 2, this is 2 one times, and this is 2 84 times. I'm reducing this by 3, and this can be cancelled by 3. 2 times is 6. And we are left with, that is 24, right, which is 8 times. Now, what you need to keep in mind that, let's say if I do it, the remaining part here, this is r square. Do not multiply, right? As we are interested in finding its square, so do not multiply. Instead, you should split 28 as 4 into 7 because we need a doublet of 7, right? Now, when we find the square root of this, that is 4 into 7 into 7. So we can see under root 4 is 2 and under root 7 into 7 is 7. So we got the radius as 14 centimeter. Now you have to keep in mind that we have to get the diameter, and the diameter, which is the twice the radius, and that is twice 14 is 28 centimeter. So this is going to be our answer for this part. In the next question, it says total surface area of a cone is 2r and its slant height is L. Sorry, we have to get the total surface area of a cone whose radius is 2r and the slant height as L. So let's say if I make a cone here, although making figure is not required in the exam, it's just for the understanding. So we have this cone and its radius, right? Keeping in mind the radius is not r over here. This is 2r as the radius, and its slant height. This slant height, this is called its slant height, right? And this slant height is given to us as L over 2. And we have to find its total surface area. Now, the formula for the total surface area, right, of a cone, right, is pi r bracket r plus L. Now, what we are going to do here is to keep pi as pi only, but we are going to replace this r with this r, that is the radius of this particular cone, base of the cone. So we have a radius this time as 2r. Same, replacing r again with 2r, and L, which is the slant height as for this figure, is L over 2. Now we should keep in mind that it's an MCQ and we should try observing what is the nearest one. So I can see that if I take, yeah, we can see we have pi r everywhere. We have 2 also. Now we need to take LCM because I can see that the closest answer comes out with taking LCM. So taking LCM, it is 4r plus 1. I can see this and this get reduced. So we are getting pi r over 4r plus 1. Well, irrespective, how do you solve? But when it comes to MCQ, you have to keep in mind that how to get this answer by simplifying this. So this should be the answer for this particular question. In the next question, we have the volume of a cone mentioned as 1570 centimeter cube. And if it is 15 centimeter high, then the base area of the cone. So what I'm doing here is making a cone first. Let's say this is the base of the cone. And then this is the cone which I've drawn. And what else we know here is that we know it's a volume. The volume of this figure is given as 1570, and its height, if nothing is mentioned, by default, it is the vertical height only denoted by h. So we have this h given as how much? 15 centimeter. Now you need to see what you have to find out is the base area. As you can see, the base is in the shape of a circle, right? You can see the base of this is in the shape of a circle. So we have to get the base area. That means the area of a circle. And for that, we need the radius. So the first part, what we are going to do is to write down the formula of the volume of a cone and equate it with the value given. So I will write volume of a cone is 1 by 3 pi r square h, and that should be equated with 1570. Now, next we plug in the value of pi as 22 upon 7. Radius is what we are seeking to find out, and h, which is 15 given, which is equal to 1570. Next, to get r square, I will be transposing these numbers, say 3 multiplied, 7 multiplied, and 22 and 5 is divided. So I'm reducing it. I can see it is divisible by 11. So 11 2 times, 11 1 times, remainder 4, 47. Right. Let's say first it reduce it by 5. If I reduce it by 5, 5 1 times, 5 3 times, 5 1 times, and 5 4 times. So we are getting this as 314, which is not divisible by 11. And we need to get it as a square. That means we must take the value of pi as 3.14. Then only it can be reduced. That is sometimes happen that as we are not able to get a perfect square here, in that case, we should take a different value of pi. Now this time what I'm going to do is to replace this pi with 3.14. And that is something we should keep in mind as we get a value something like 157 or double of 3.14. We should take it. So I'm taking it as 3.14. So let's see r square. I can reduce it a part of it like 3 1 times, 3 1 times, and 3 5 times. Right. In the next part, now I'm isolating r square in order to get its value. So for that, I'll be dividing with 3.14 multiplied by 5. So what I'm doing here is transposing this 5 and 3.14 on the other side. Now I can remove this decimal and instead multiply by 100. This is divisible by 5 times and 5 one time. So r square is equal to 100. So r is equal to 100, that is under root 100, which is 10. So something that you have to keep in mind in this question is, although generally it is mentioned what pi should be taken, but sometimes not mentioned, then we justify it like this. So we got our radius as 10 centimeter. What we have to get the area of the base, as I told you, the area of the base is in the shape of a circle and its circle area is pi r square. So what we are going to do is just to place the value pi as, no, this would be taken as 3.14 as for the question, and r, which is 10. So 10 square is 10 into 10. This is 3.14 into 100, which is 314 centimeters square. So this is our answer in this case. We have another question. It says a conical pandal has 240-meter in radius. Pandal is something just like what you can say, uh, a tent only, which is 250-meter, yeah, in radius, and 10-meter high, is made up of a cloth which is this much 100 pi meter wide. Then the length of the cloth needed. So for that, what you have to remember that, let's say this be the cone, and the base of the cone, let's say this being the cone. What is important for you to remember that only the curved surface area of the cone, only the curved surface area of the cone is used in making the material, right? I mean, the material which is used in making the cone is only involved in the curved surface area and not the total surface area. That means only this portion of the cone, right? This portion of the cone, that is its curved surface area, should be considered. And it is actually made from a sheet, rectangular sheet like this, right? I mean, a paper or a cloth, whatever it is, depending upon the question. Eh, So what I can see that we know the width of this cloth, which is 100 pi, right? And the length of this cone is this, and we do not know the length of this cone. This is what we have to find out. So clearly you can see that they must be of same area. The area of this figure must be area of the curved surface area, right? The area of this figure is actually length into breadth, and area of this is pi RL. So we can equate these two. Now what I'm going to do, as for the question, we can write out that area that is here. As for the question area, say A1 and A2 are equal because it is the same rectangular sheet of cloth is used in making the curved surface area. Area of this rectangle is length into breadth, so that is L into B, and area of a cone is pi RL, so that is pi RL. Now length is what we are looking to find out. Width, which is given as, right? The width of this figure is already given as 100 pi. So keep pi as pi only. And this is pi. The radius of this in meter is 240. So I'll be writing this as 240. Now keeping in mind that I should use different symbol as L because they are denoting the different values. And the length or the curved surface length is the slant height. That is this L is the slant height here. We need to get this value L, which is under root R square plus H square. So L is equal to R is how much? Yeah, it's 100-meter high. So R is 240. So it's 240 square, and H, which is 100 meters. So it's 100 whole square. Now L, which is 24 square, is 576, followed by 2 zeros. And this is 1 followed by 4 zeros. So that means we are going to get this value as, I can do it here, right? I can get this L over here. This is 676 followed by 2 zeros. 576 I added with 100, 676. Next, you know that under root 676 is actually 26, and there is 2 zeros, so it should be 260. So we got this slant height, right? So I'm replacing this L, right? I'm replacing this L with its value, that is 260. Now for the remaining part of the working, I can see that pi and pi get cancelled, and I have to get L. For that, I'll be transposing the 100, that is 240 into 260, that divided by 100. So we see that these zeros get cancelled. So the final answer will be obtained by multiplying. So that is the length will be 24 into 26. So that is 24 into 26. We'll calculate this. That comes out to be 264. Yeah. So 624 meter. And that is the length. And we got this length, right? This is a very important question. So in the next question, it says the curved surface area of a cylinder and a cone are equal. And if their base radius is same, then the ratio of their slant height, sorry, the ratio of the slant height of the cone to that of the height of the cylinder. Right. So what we can do, the curved surface area of cylinder, let's say if I make a cylinder first, this is what I'm going to make a cylinder. It's always easy if you make a rough sketch. And then I'm going to make a cone, keeping in mind that their bases are same. It's not should be up to a scale, right? So in this question, what we have already, we know that their radius, say this is the radius of this figure, which is equal to the radius of the other figure. And the curved surface area of the cylinder and the cone is equal. That means curved surface area of cylinder is 2 pi RH, right? And the curved surface area of cone is pi RL. This is given equal to us. As I read, curved surface area of a cylinder is and a cone are equal if they have the same radii or the radius, then the ratio of the slant height, that is L, to the height of the cone, that is H. So what we are required to find out in this figure is to L over H. L over H is what we have to find out. You should keep in mind that the first is the slant height and then the height of the cylinder. So what we are going to do is to first write down the relation which we already have. We already know that here that the curve pi RL, curved surface area, is equal to 2 pi RH. This is what given to us. So I can cancel pi and pi. We have the same radius and that's why I use the same symbol. Okay, this is L over H. So what I'll do, first I'm writing this. And then I'm transposing H to the left as we are required to get L over H. So this is 2 over nothing. That means 2 over 1. So the required ratio is going to be 2:1. This is the answer for this figure. We have another question where the ratio of the radii of the bases of two cones are 3:1 and the ratio of their heights is 1:2. Well, it is not necessary to make the figure that we should make it, but for understanding, I'm making it for you to understand better. We have this cone here and one say the other cone. I'm considering the radius of the first say as R1, this being R2, and the ratio of their height, let's say this is H1 and this is H2. So what do we have? We have the ratio of R1 over R2 as 3 over 1, and we have H1 over H2 is equal to 1 over 3. It's not up to a scale, right? What we have to get is the ratio of their volume. That means we are required to find out. V1 over V2. That's our question. So for that, what we are going to do is to apply V1 formula of volume, and which is 1 over 3 pi. R is replaced by R1 square into H is H1 here. And this is 1 over 3 pi R2 square H2. Now you see that 1 by 3 pi get cancelled. And if we write this is V1 over V2. I can write this R1 square by R2 square as R1 over R2 whole square and replacing H1 and H2 as this only, H1 over H2. Now what next? We just plug in the value. Now I'm replacing R1 by R2 as 3 by 1. So it's 3 by 1 square and H1 over H2 as 1 by 3. So when you simplify, 3 with square get cancelled because it is 3 into 3, right? So we get 3:1. right? 3/1 is 3:1. So the D is the correct answer for this.